Good morning, David and classmates. This is my building systems project, designing green building. So my site is located at 66 Jalan Bincang, which is near the Bishan MRT there. So we can see from the diagram to the right that wind normally comes from north and northeast. And from the picture on the left, um, we know that the sun hits hottest during the month of May at approximately like 12 p.m. around there. So the house that I'm doing is the rewrapped house, which is a previous assignment, the house that I did. So I built it on Revit, and here we can see I put it on the inside and inside 360, and you can see the building form and the EUI mean. The EUI is actually energy usage intensity. So we can see that the EUI mean is not very good. It's 142. So my first implementation is the building orientation. So looking at the inside of the Autodesk, I saw that I could reduce the EUI by simply orientating my building. So currently from 90 degrees, if you rotate it to 315, you get um, you get to minus some kWh. So yeah, that's the first implementation that I did. So to add on to better the EUI mean, I've come up with four different implementation. So my first one is actually a cross ventilation. So cross ventilation is a natural way of ventilating a building by allowing fresh air to flow through it. It works by like opening windows on opposite or adjacent sides of the building. So meaning that the north one, the air can go through the east windows. So that's what I did. I put windows on all sides, so the possibilities of cross ventilation from opposite ends to the other and adjacent ends is possible. So both ways are possible. So it maximizes cross ventilation. So the second implementation I did is daylighting. So as you can see from the diagram at the top right, that is my house in Revit, and we can see that we have a skylight at the top. So the implementation of skylights reduce the need for electricity. It is implemented because it allows natural light to enter a space, which can help to reduce the need for artificial lighting and lower energy costs. So, um, with lower energy costs and the lesser need for artificial lighting, it also means that it will lower your electricity bill, which also means you get to save money. So my next implementation is actually window shades. So you can see from the middle top diagram, you can see the window shades. So it is recommended that you put it to 2 thirds. So that's why I extended my roof out a little to cover the curtain wall, so it can reduce some of the sunlight going in. So and my next point is also PV panels, photovoltaic panels. So um, you can see from the bottom right how the photovoltaic solar panels actually work. So the energy source, which is the sun, then the sun rays come and hit the PV panels, which then convert it to electricity, which is ready for to be used as energy. So basically, PV panels just allow us to generate electricity from sunlight. So this reduces cost over the long run, is better for the environment, and it makes your need for electricity from power grids almost non-existent. So my last implementation is actually motion sensor lights. So motion sensor lights save electricity as it only turns on when they detect presence. So you can see from the picture at the right, this is like a rendered picture of my house in Revit. The top is motion sensor lights. So when you come in, it will turn on. It will turn on, yeah. And when you go out, for example, it turns off. So it basically just detects presence. So if you're not there, it's off. So this reduces electricity bill, which in turn saves your money. So in a situation where your hands are holding something, carrying something, and you come down at night, you don't need to look for the switch. You don't need to use your flashlight. as it automatically turns on. So after implementing these strategies, we can see the EUI mean improved drastically, getting to a 19.8. So yeah, thank you.